Recently, someone asked me how one could make an aim constraint for some objects without actually using a constraint, using pretty much just utility nodes. And they sort of defined a situation using multiple objects and basically several things which I tried to make work, but I couldn't quite figure out how to do it. There's just a couple of nodes I know that I probably should have used that I wasn't sure about. But still thinking about it, I came up with a way that's actually pretty simple and actually doesn't need as many parts as they had actually specified. Also, still just using utility nodes. As a matter of fact, it just uses one type of node. It uses a multiply divide node. And so that setup pretty much goes like this. So I've got an arrow, got a joint, I've got a cube. Basically, I'm just going to use the cube as my target. It's going to basically be the object that the arrow needs to basically constantly look at. And I'm going to use the joint as sort of the object that's actually controlling the arrow. This is just so that, let's say if I wanted to swap out the arrow, I could easily do so and still have the setup work just by reconnecting something else to the joint. So you could create the setup controlling the object directly, but if you actually want to make something actually a little more modular, this is kind of the way you do it. You basically use a joint or some other object like a locator as your base. Okay, so the setup's pretty simple. First, you need to create a couple of nodes. Like I said, the multiply divide node. So simply go to your Hypershade window, which is located under Window, Rendering Editors, Hypershade. Go to Utilities, and you can create a multiply divide node. There's also ways you can do it from the command line. You just tell it to create a shading node and then specify the node type, but this is pretty quick. So create the node, and of course you want to actually name your nodes. I'm just going to name it something simple. I usually name mine mdiv for multiply divide, and then underscore something to specify what it's going to do. Now this one I'm going to have actually control the rotation of our arrow, so I'm going to call this one my mdiv aim. And then we're going to need a second multiply divide node. I'm going to just duplicate it, Control D, or Command D if you're on a Mac. And I'm going to call this one my mdiv, and we'll call this one offset. Okay. And so now let me just check on a couple of things. So first of all, when you have your cube, you want to do one thing with the cube. Put the cube at its, put your control at whichever its default position is going to be, and then you want to create a group around it. So my default position for this one is a few units away from the arrow, and I'm going to select it, press Control G, create the group around it. Okay, and so now we have our group underscore, and I'll just call it control. Okay, and then we also need, of course, the joint, and we call this one my joint aim, or I call it my pivot joint or something like that. And then we have, of course, have our arrow. Now, what you're going to do with the arrow is you're going to take the arrow and you're going to connect it to your basically your aim object or aim joint, whatever object you're going to be controlling to control the rotation. So I'm just going to parent it to it, just a regular parent, not a constraint. You could use a constraint if you chose. That's up to you. Okay, so now we have the joint, in this case controlling the arrow. Okay, and we have our cube, which I'm going to call my control, and that's going to be controlling the movement. Now right now it's not going to control anything. We just have all our component parts ready. So now we need to start making the connections. So I have my constraint, my mdivs, I have my control objects. So what I'm going to do first is I'm just going to select my cube. I'm going to shift select my mdiv for the aiming, and I'm going to load it into the connection editor. So general editors, connection editor. You could also use the node editor. It just depends on what you're more comfortable using. I find the connection editor is actually pretty good and pretty fast for most things. So now we need our control. We need its translate values to feed out to the multiply divide node. Now, one thing you have to consider when you're making connections, you have to remember that the rotation or the translation of your control is going to be controlling the rotation of this object. Now you want to pay attention to the orientation of the object that's being controlled. Now its x runs left to right, its y runs up and down. So in order for this to actually rotate, to basically rotate up and down, it would actually have to rotate on the x-axis. For it to actually twist, it has to rotate on the y. Now, in the case of the control, it's translating along the y. And so if we want the arrow to actually basically aim at it when it's actually translating up on the y, that means the translate y of our cube needs to control the rotate x. Okay? So when we're setting up our input for our node, we want to actually take that into consideration. I usually like to do it on the input instead of on the output. You can do it either way, but I'm going to do it based on the input. So in this case, instead of having the translate x of my control feed directly into, let's say, the x input of my multiply divide, now I'm going to feed it into the y, because I want the x, which is going left to right for the cube, to control the rotation from left to right of the joint that's controlling the arrow. And same thing for the translate, up and down, I want that to control the x on my control object. So I'm going to feed it into the x of my multiply dividing. Now we don't need to do anything with the translate value because we actually won't need it here. Next, now we need to take our multiply divide node with the aim and feed its output into our joint. So I'm just going to reload the left. I can make sure I can show non-keyable so I can see the outputs. And then I'm going to select the joint, reload it on the right side of my connection editor so that it's basically being fed, it's on the input side. Make sure it's not showing the non-keyable, so I can just show the specific attributes I need to control, which is in this case is the rotation. And then what I want to do is I want to take the output x and feed it into the rotate x, and the rotate output y and feed it into the rotate y. Okay, so now that those connections are made, I can just do a quick test. I'm just going to move this window out of the way and move this window aside. I'm going to keep it open just in case I need to make some other connections. So I take the control, and you can already see that our control is influencing essentially the joint, which is controlling the arrow. That's what the magenta color indicates, that there is a connection. So if I translate now, you see that it does rotate the arrow along the x, except that it's rotating, it's not rotating enough, and it's rotating very, very little. But that's okay. We just wanted to make sure the connections are working. Now the x is actually working perfectly, okay? So we know that works. So if I actually translate this up, and I'm just going to go to my channels box so we can actually see what's going on here. You go to the outputs, you can just click on the mdiv aim. You can see that our input x is only receiving a very, very, very low amount of rotation. And that's because it's basically only moving about, it's telling it to rotate only about 1.6, in this case, degrees instead of units. So we need to actually multiply that value. Also, if you notice, when I translate it along the y, it's actually rotating in the opposite direction. So we can easily fix that just by going to our mdiv aim on the, in this case, the y, the x input, because it's the y feeding into the x input. And we can just multiply that by a negative number to do two things: to change the direction and also to increase the amount of the value that's being input. Okay? So now you can see that's actually working perfectly now. Okay? So it's not aiming at it, but it is rotating up like we need. Okay, and we do the same thing for the y value. We set to 20, so that, and this is so that the influence is equal. Okay, so it's influencing an equal amount in both cases. Okay, so we know that part works. Now the next part of the setup, so that we can actually make sure that the control is always basically in front, or basically being aimed at by our object, is to basically take the group that's around it, and we're actually going to just parent that in to the joint that it's controlling. Okay, so you want to remember one thing when you're actually when you're actually parenting your group to your control joint or locator, whatever is basically controlling the rotation. Make sure that when you actually have your group parented to it, that you freeze the transformation so that its translates are 0, so that essentially its current position, its current association, the translates are at their 0 default before you make any additional connections. Now, Many of you might say that this is a bad idea. Now, yes, it is a bad idea because what does it cause? It causes what's called a double transform, meaning that when I translate, it's going to basically translate away from what it's connected to because it's basically being fed the translation information twice. Okay? But that's what our second node is for. Our second node is basically to counter that double transformation. And so now what we're going to do is we're going to take our connection editor, come up, and we're going to select our mdiv offset node, reload it on the right side, take our control, reload that on the output side, and we're going to feed its translation output from the translate X and translate Y into the input X and input Y. Now in this case we don't need to cross anything because we're actually going to feed these directly into the translate X and the translate Y of another object, or in this case of a group, the group that's around our control. Now one thing you want to do with the mdiv offset before you make any connections is come in and set its input to X values to -1 so that it's basically doing exactly what I suggested. It's going to feed the positive translation of the control into the node and output a negative, so it'll basically counteract the double transformation. Okay, and so now we have our value set, we have our offset node, we're going to reload that into our input side, into our output side, and now we need to load the group that's around our control object. So I'm going to the outliner, expanding, find my group control, I'm going to reload that onto my input side. And so now from the outputs, left display, show non-keyable, output, I'm going to feed the output X into the translate X and the output Y into the translate Y of the control group. Okay, so now when we actually come in and look at our control and we translate it, our control stays aligned relative to what, basically relative to the object aiming at it, and it's also controlling the angle at which the object is looking. Okay? And so that's always going to be along the X and the Y. The Z really won't do anything, so you can actually take that, the Z axis, and you can lock it. Now if you do want to use the Z axis, you can. It's just that you'll have to throw in a little extra component so that if the control does cross the Z axis of your object, that it'll automatically flip the object around so it's actually facing the right direction. And that's pretty simple. You can use a set-driven key, you can use an expression, or even simply use a condition node so that if this object crosses the z-axis, it'll automatically set the rotation of, let's say, the object on the top level to basically equal to 180. Not the joint itself, but the object that's controlling. You can just have it flip it around so it's actually facing the right direction. Pretty simple, but also a little unnecessary, because you can just simply lock that off so that you're translating always in the right direction. Now, if anyone thinks that this is moving too fast, you can simply come into your mdiv and just decrease the amount that's actually being multiplied times the translation value. And since your control object is parented to the object, it'll always adjust, so you can actually have it react slower or faster depending on the multiple being fed in. Now, while this setup does a great job of controlling the rotation of our aiming object, remember that it's not a true aim constraint. It doesn't really have a sense of the world space. It's paying attention to one thing. It's paying attention to the position of your control, and it's basically translating its translation value into a rotation value directly. So there's no sense of world space. So it's not a true aim, it's just sort of a simulation of an aim. So that's just something to keep in mind, because if you actually reposition the object that's actually being controlled by your controller, you can see that it also displaces your control object. Okay, so the aim only works from one end, not both. So that's something to keep in mind if you're going to choose to use this setup for something.